let S be this set. S contains all the natural numbers starting from 1 up to 2022. Then we have to find the probability that a randomly selected number n from this set S will satisfy this condition that HCF of n and 2022, this is 1. Now, problem based on this HCF of a number and another number equals to some fixed number. This is not uncommon in JEE Main. You'll find multiple problems in permutation and combination, as well as few problems in probability based on this concept. So in these type of problem, basically the problem is we have to find how many numbers are there in this set for which HCF of that number and 2022, this will be 1, because obviously total number of cases will be 2022 and we need the number of favorable cases, then probability will be number of favorable cases by total number of cases. So in such type of problem, the very first step will be that whatever that other number is, write the prime factors of this number. Right, for 2022, the factors will be, you can have 2 and then 1011. So that will be 3 into and then 337. Right, these are the prime factors of 2022. 2 and then 1011. So that will be 3 into 337. And it is given that HCF of n and this number, this must be 1. Also remember 337 is not when 337 is a prime number, and if I have to check whether 337 is prime number or not, so you can check up to its approximate square root, right? For example, 19 square is 361. So you can check whether this is multiple of 2, 3, 5, 7, 11, 13, 17 up to 19. Right, if there are no factors up to 19, then you cannot have both the factors bigger than 19. Right here, and the logic is also very simple, because 19 is square, this is 361. So for this number, if there are no factors smaller than 19, then there will not be any factor bigger than 19, because if I say that one factor is 23, then other factor has to be less than 19, then only the product will be 337. So whenever you need to check whether a number is prime number or not, you can check up to its approximate square root. And when you check for these numbers, you'll find that this number 337 is not multiple of any one of these numbers. And after this point, you should not check, right? Now here, if HCF of n and this number is 1, so from this line we can conclude that n cannot be multiple of either 2 or 3 or 337, right? This number n, this is not multiple of 2, because if n is multiple of 2, then obviously HCF cannot be 1. Suppose if n was 2, then HCF will be 2. If n is 4, then also HCF will be 2. So n cannot be multiple of 2. Similarly, n cannot be multiple of 3 also, because if n is multiple of 3, then HCF will become 3. And finally, n should not be multiple of 337 also, right? N is neither multiple of 2 nor multiple of 3, and nor it is multiple of 337, right? So now we have to find that how many numbers are there in that set which will satisfy this condition, that it is neither multiple of 2 nor multiple of 3 nor multiple of 337. And for that, here I'll write, first let us see that how many numbers are there which are not multiple of 2, and then we'll consider the other two fact that it should not be multiple of 3 and 337. So if n is not multiple of 2, it has to be an odd number. So the different odd numbers are, you have 1, then you have 3, 5, 7, 9. I'll write just few numbers so that you can see the pattern there, and then the calculation will be much easier. So next you have 13, then you have 15, right? And maybe I can write one more, 17. And in this manner, the last odd number is 2021. And remember, from here we have to remove multiples of 3, and we also need to remove multiples of 337. So if I remove multiples of 3, you cannot take n as 3, because in that case HCF will not be 1. So it is not 3, it cannot be 9, it cannot be 15, and so on. Now there is one interesting method of finding how many terms are there which are multiple of 3. Here if you notice, These are the three terms. And out of those three, one is multiple of 3, other two are not multiple of 3. Similarly, if you think of the next triplet, 7, 9, 11, I mean, obviously there are multiple ways of solving this one. One, you can use the AP formula, the multiples of 3, 3, 9, 15 and so on, that will form one AP, right? So that also you can do, but this technique will be much easier. So here out of every 3 number, we are getting one multiple of 3. So here if we talk about numbers which are uh, satisfying that condition, that means we have odd numbers, I mean total number of odd numbers, this will be 1, 0, 1, 1, right? Total 20, 22, half of them are odd number. So in this series, starting from 1 up to 2021, the number of odd numbers are 1, 0, 1, 1. But out of those 1011 numbers, 337 numbers are multiple of 3. How I got this 337? So from these three numbers, in every triplet, you have one multiple of 3. Right? In 135, you have one multiple of 3, 7, 9, 11, another multiple of one multiple of 3, and so on. So 1011 divided by 3, that will give us 337 triplets. And every triplet has one multiple of 3. So these are multiples of 3. And remember, we also need to remove multiples of 337 because a number cannot be multiple of 337 also. So now let us count how many multiples of 337 are there. So obviously one number will be 337 into 1 that is present in this series. We are writing only odd numbers, so 337 into 2 is not there. 337 into 3 we have removed with multiples of 3, right? Here when this 337, this these 337 numbers of multiple of 3, they will include 337 into 3, and again 337 into 4 will be even number. So next number 337 into 5. These are, and after that 337 into 7 will be bigger than this number. So these are the two multiples of 337 which are present in this series as odd numbers, and we have not removed them as multiple of 3, right? So another two multiples of 337, and this divided by total number of terms 2022. So these are the I mean this should be the probability. Total number of cases 2022, select any one number from there, and number of favorable cases means the number of numbers satisfying this condition that HCF will be 1, that will be 1011 minus 337 minus 2. And after calculation, you will find that this number will become 112 divided by 337. This calculation you can do on your own, and therefore the correct answer will be fourth option. So these HCF type problem, they are not difficult. Just you have to be familiar with the basics that if HCF is 1, the number cannot be multiple of 2 or 3 or 337. Right? First write prime factors of this one, and then total we got these many numbers. After simplification, the correct answer will be option D.